take this, because let's say we have this length and then this length broke down two lines. So let's say this whole line is A and this whole line is B. Another right angle triangle, which is this, and then we can find another length of BD here. So the BD, another BD is equal to the square root of 225 minus B square. Hey guys, it's Mathematics YT. Today I'm going to solve another geometric problem. So here's the question. I have a triangle ABC D and it's a right angle triangle, and the length of BD is perpendicular to line of AC. So the question is, they want you to find the length of BD and the area of triangle ABC. So if you guys are interested in this question, please pause a while and try it for yourself. So let's start solve the question. So let's find the length of AC, but how can we find the length of AC? We can use Pythagoras Theorem. So the length of AC is equal to the square root of 20 square plus 15 square, which will leave us 25. So this length of AC is 25 centimeter. So we have everything lined up. So let's start solving question A. So for the question A, they want you to find the length of BD, but is it possible? Yes, it is possible. We are going to use some algebra inside this. So let's say we take this, because let's say we have this length and then this length broke down two lines. So let's say this whole line is A and this whole line is B. So we can conclude that A plus B is equal to 25. And then the next step, we need to find the height, we need to find the length of BD in terms of A and B. So we have this right angle triangle. I have illustrated everything inside here. So we have 20, we have A, this is not 9, this is A, and then we have BD. So we can find the length of BD by using Pythagoras Theorem. So BD is equal to the square root of 400 minus A square. This is what we get. But there's another possibility. Let's say I have another right angle triangle. We have another right angle triangle, which is this, and then we can find another length of BD here. So the BD, another BD is equal to the square root of 225 minus B square. Now we can observe that these two lines are same. So I can conclude that square root of 400 minus A square is equal to square root of 225 minus B square. And then we need to simplify this equation. So 400 minus A square is equal to 225 minus B square. And then we take this to here, and then we add this to here. So negative A square plus B square is equal to 225 minus 400. So negative a square plus b square is equal to negative 175, and then we multiply by negative 1, so a square minus b square is equal to 175. And then we have a simultaneous equation 25, and then a square minus b square is equal to 175. So I have summarized these two equations. So since these two are relevant, I can conclude that these two equations are simultaneous equations, but it's not simultaneous linear equation. Simultaneous linear equation is they have two linear equations that are relevant, but this is not the simultaneous linear equation. It's I have an linear equation and I have a non-linear equation. For the first step for this equation is we need to factorize this expression out. So we have a minus b times a plus b is equal to 175. And what things happen is we need to substitute this a plus b inside here. So we have 25 times a minus b is equal to 175, which will lead to a minus b is equal to 7. This is amazing. We have made the non-linear equation become a linear equation. So let's rewrite down the simultaneous equation. A plus b is equal to 25 and a minus b is equal to 7. And then what I'm going to do is we can use either substitution or elimination method, but for me I can use elimination method because there was an opening. What kind of opening? You look at this. I have plus and minus, which means what? I can just sum it up. So 2a plus b minus b, which will lead to 0, is equal to 32. So a is equal to 16. We have found the length of a. We have found the value of a, but if you want to find the value of b, I guess you don't have to, because what we need to find is the length of BD. But I have this in terms of a. So what I am going to do is BD is equal to square root of 400 minus a squared. So BD is equal to, you just substitute the value of a, so 400 minus 256, which is equal to square root of 144, which is equal to 12. So the length of BD is equal to 12. But if you, just in case, if you want to find the value of B, you also can. So a minus b is equal to a minus b is equal to 7. A plus b equal to 35, and then 16 plus b is equal to 25. So b is equal to 9. And then what I'm going to do is I'm going to take this length of BD in terms of b into here. So BD is equal to square root of 225 minus b squared, which will equal to 225 square root of 225 minus 81, which will lead to square root of 144, which is equal to 12. So length of BD is equal to 12, and then we have same solution. So I can conclude that the length of BD is 12 centimeters. Let's start solving question B now. As the question B asks, they want you to find the area of triangle ABC. So how do we find? Well, it is a very simple solution. You just 1/2 times base times height. So the area of this right angle triangle is 1 over 2 times 15 times 20, which is equal to 150 centimeters square. 150. Besides we can use these two sides, we can also use these two things, because in form of like this, in form of scaling triangle, we can found that this scaling triangle, the area of also can be 1 over 2 times base times height, because this is B, this is H, so times base times height. So I can also write down as 1 over 2 times 25 times 12, which is also equal to 150 centimeters square. Now, the another thing that I can use is I have this. I have a scaling triangle, and I have length. I have 3 different lengths. And then you might wonder, what is the area for a given this only 3 lengths? There's no height, no angle. An angle doesn't count. No matter what angle you put, it also will get the same solution. So the answer for this is, so we can do another formula, so which is 1 over 2 times 20 times 25 times 20 times 25 times sine of cosine of -1 of, let me just write everything down here, of 20 square plus 25 square minus 15 square over 2 times 20 times 25. This will lead us 1 over 2. This will lead us 250 times sine of cosine of -1 and 4 over 5, which will also get us as 150 centimeters square. Well, how do you find that thing? Well, I will explain it another video. So if you guys really interested how I prove the area of the triangle with the given 3 lengths, so just keep subscribe and leave a like on this video. So see you guys next time.